So busy day today. So I want to get going right off the start. So we're gonna finish up solving equations today. We're going to do a little self-discovery or mini group discovery on proving trig identities today. We'll pick that up again tomorrow. And then I've got a ton of stuff to hand back. I've got formative to hand back. I've got homework to hand back. I've got test to hand back. A bunch of different stuff to do that. So if you guys want to get started with a couple of warm-ups, these are not solving warm-ups. These are just straight up simplifying type ones. So probably should have put that in there. Okay. So simplify those two expressions. I'll give you 4 minutes. Alrighty, here we go. Let's start with the left one first. Okay. So secant, that is going to become 1 over cosine. Sine is going to stay sine. Tangent is going to be sine over cosine. Okay? Now, when we get to when you are doing these problems, you need to show all of your logic. Or more importantly, show every single step. You don't get the luxury of skipping steps and doing steps in your brain, because I can't read your brain when I'm correcting these homeworks or these tests or these formatives or whatever we're doing. Okay? So on Thursday of next week from today, when we're taking our test, we got to show, or you are going to have to show all of these steps. That's your job. My job is to go through and follow your steps and make sure that I can follow along and it's mathematically sound. Okay? So we each have a job to do. Okay? So then this would become 1 over cosine minus sine squared over cosine, which then would become, and this was a step and a problem similar to this one on the formative that some people showed, some people didn't show. You should show then the combination of those two fractions. Okay? So you would have to show that. Then you can say that 1 minus sine squared is cosine squared. Then cosine squared divided by cosine is just cosine of x. Okay. In the second one, one plus tangent squared is secant squared. Then cotangent is cosine over sine. Secant is 1 over cosine, so secant squared is 1 over cosine squared. Tangent is sine over cosine. Key change flip. The two cosines on the top cancel out the two cosines on the bottom. So that then gives me 1 over sine squared, which is cosecant squared. Questions on either one of those? Okay, love it. So let's jump into some solving. Remember that when we're solving, we always solve first lap of the unit circle. Okay. So if I'm presented with something like 4 cosine squared of x minus 3 equals 0, okay, I can add 3 to both sides. All of my algebraic rules still apply. For cosine squared of x equals 3. I can divide both sides by 4. I can square root both sides. Because I'm solving and I'm taking the square root, what comes into play? Plus or minus. Square root of 3/4. For 3 over 2? Yep. Because this would be square root of 3 over the square root of 4. So that would be plus or minus the square root of 3 over 2. Okay. So where is cosine positive root 3 over 2? First lap. Where is cosine positive root 3 over 2? Pi over 6. And 11 pi over 6. Where is root 3 over 2 negative? Or excuse me, where is cosine negative root 3 over 2? First lap. Anybody? So all 4 of those then become the solution. Ideally, you would write them in numerical type order, but if not, that's fine. Questions, comments, concerns, clarifications? You try solving this one. So, if I can't divide, what can I do? I can factor. Words to live by. Don't divide, factor. Okay? So I need to get everything onto one side. So I'm going to subtract 2 secants of x from both sides. So that's going to give me secant squared of x minus 2 secant of x equals 0. And now I can factor out a secant of x. That's going to leave me with secant of x minus 2. Once I factored, then I set my factors equal to 0. And I solve those. Secant of x equals 0, secant of x equals 2. Okay. Now, I've got to ask myself, where secant is what again? 1 over cosine. So if I reciprocate this side, I would have 1 over cosine. Oops, excuse me. So this is 1 over cosine equals 0 over 1. Got ahead of myself. If I reciprocate this side, I get cosine of x. If I reciprocate this side, I get 1 over 0. Can secant ever be 0? No. And if we remember to our graphs in the last unit, remember that secant was parabolas. Okay? Endless repeating cycle of up opening parabolas and then a down opening parabola. An up opening parabola and a down opening parabola. And the closest it ever got, or the smallest it ever got, was -1 and +1. It stayed out of that middle zone. Okay? So this one can't happen. Nothing's going to come out of that one. Following the same logic over here, 1 over cosine of x equals 2 over 1. So that would be where the cosine of x equals 1/2. Where, first lap, unit circle, does the cosine equal positive 1/2? Pi over 3. 5 pi over 3. So those then become the only answers that make this work. Okay? You might have this kind of a problem. What's wrong with this one? Why can't I factor? Okay, there's no GCF. But why also can't I factor? Two different trig functions. Yeah, I've got two different trig functions going on with addition and subtraction. It'd be easy if it was just multiplication, right? So can I do anything with those two different trig functions? We could use, is that number 7? I think so. Yeah. So if we took sine squared and made it be 1 minus cosine squared, now I've got one trig function. So let's work that. So this would then be 2 minus 2 cosine squared of x plus 3 cosine of x minus 3 equals 0. Do we want to keep everything on the left side, or should we move everything to the right side? Which one, Zoe? Why do we want to move everything to the right side? Because we get a positive squared term? Yeah, because we get a positive squared term. Okay. Now what can we do? If I had a little think box off to the side, kind of like what we had yesterday. And if I said in my think box, 0 equals 2y squared minus 3y plus 1, and we had to solve that, thinking of cosine as our variable, what would we do? Can't divide, gotta factor. Right? So way over here, what does this factor to be? Two y and y? 1 and 1? Plus, minus, minus, plus, 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 minus, minus. Minus, minus. Does that work out? Yeah. Same thing happens over here. Quick mental check. If I multiply these two together, I get my 2 cosine squared. If I multiply these two together, I get negative 2 cosines. If I multiply these two together, I get negative cosines. Negative cosines plus negative 2 cosines gives me negative 3 cosines. And if I multiply these two together, I get positive 1. Now I can set my factors equal to 0. First lap, unit circle, where is cosine equal to 1/2? First lap, where is cosine equal to 1/2? Pi over 3 and 5 pi over 3. First lap, unit circle, where is cosine equal to 1? 0. Questions, comments, concerns, clarifications? Try that one. From my lap around the room, most of you did this. Yes? Good so far. But from there, lots of people just quit. Okay? What are our options here? So, okay, so here, let's get to this one. So 3 Okay, we move the 2 over, and then what? Yeah. Okay. Oh yeah. Okay, so because we got a fraction, so we need to, one, we either got to have common denominators in order to combine them on that side, okay? Or what's option 2? Multiply the entire thing by cosine and get rid of the fraction. Okay? Either way. Okay? I'm going to go with common denominator way. When I do this problem, I multiply by cosine. But I'm going to go with common denominator way because I saw some people do it that way, and then they made one crucial mathematic mistake. Okay? So this is going to stay, oops, this is going to stay 3 over cosine. This becomes cosine squared over cosine. Agree with me on that. Okay? So then the left side here becomes 3 minus cosine squared over cosine. Right? Okay? Now, where I saw a lot of people make a mistake was way back in that warm-up problem I told you about it too. I can't cross out a cosine here because it's a binomial on top. So I can't do that. So now here, I would have to multiply by cosine. So either way, option 1 or option number 2, you're going to have to multiply through by a cosine at some point in time. If I multiply this side by cosine of x and this side by cosine of x, then I get 3 minus cosine squared equals 2 cosine. Now if I get everything onto one side, I would get 0 equals cosine squared of x plus 2 cosines of x minus 3. Cosine times cosine gets to be cosine squared. What two numbers multiply together to be negative 3 and add to be positive 2? Positive 3 and negative 1. Set those two factors equal to 0. Solve them. Where first lap, unit circle, is cosine negative 3? Nowhere. Can't be. It's got to be between 1 and negative 1. Okay? Where first lap, unit circle, is cosine equal to positive 1? 0. So my only answer here then is 0. Okay? Good times. So now what we're going to do is we are going to move from solving to proving trig identity. And the way that we go about proving a trig identity is we work one side. You can only work one side in a proof, and you have to make that one side look like the other side. And that's how you know that you're done. You keep working that one side until you've got the other side. If you don't have the other side, you've not proved anything. Now, with that being said, which side should we look at when we're looking to do stuff with? The easiest side, the prettiest side, or the ugliest side? So you're going to look at the ugliest side. So for instance, on the worksheet that I just handed out, or the note sheet that I just handed out, in the algebraic example, x squared minus 1 over x minus 1 minus x squared minus 1 over x plus 1 equals 2, I can only look at one side. Well, which side can I do more stuff with? Left or right? We can do more with the left side. So we're going to ignore this side. And we're only going to work the left side. We're going to be simplifying that stuff that we just did. Come on. This stuff. That's why we had to learn this stuff first. Because if we want to prove it, you're doing this. It's just now you know what you got to get. You got to work that until, and I would be working this side. I'd work this left side until it's 2. Doing all of the maths possible when we get into trig, using all of the trig identities possible. Okay? This sheet is a self-guided sheet, so you can follow along and you can know that you're right when you get the other side, kind of a deal. Okay? While this last mod, you're going to be working on that, I'm also going to hand out here next a 5.1 solving worksheet, so that'll be your third worksheet. Side note, you need practice with this stuff. That's the only way you're going to get better so that you can perform on next Thursday's test. So you have 3 worksheets now, or you will have 3 worksheets here in about 5 minutes. Okay? You should be done with at least 2 of them by the end of today. Okay? Tomorrow you're going to get another one. We're going to keep giving you worksheets because you keep needing this practice. Okay? All right? So the rest of the class, you're working on the notes on this white 5.2 Proving Trig Identities Day 1 sheet. And then if you get done with that, then you can start working on worksheets.